Hi there, this is Guided Practice 11 from section 4.3, the product and quotient rule. And so I just wanted to remind you before we get started that product rule here is 1 prime 2 plus 2 prime 1 or 1 2 prime, whichever way you want to look at it. So a quick example here, if I let function 1 be the x squared, then its derivative is 2x. And if I let the function 2 be the x plus 1, its derivative is 1. So if I put that back together here, h prime of x, then I'm getting 1 prime 2, so 2x times x plus 1, plus the other diagonal, which is x squared. And if we simplify, that's 2x squared plus 2x plus x squared, and that's 3x squared plus 2x. Okay, so a quick, easy example of product rule. Nothing crazy, so the other ones are going to be a bit more difficult, but the idea that we're doing 1 prime 2 plus 2 prime 1. Quotient rule. You've got n and d here stand for numerator and denominator, but you can also think of it as just top and bottom. And so in this case, my top is the x squared plus x plus 3, and the top prime, the derivative, is 2x plus 1. For the bottom, that is, and actually let me get rid of this and move it up. The bottom is x minus 4, and its derivative is just 1. So when I go to find the derivative here, I want top prime bottom, so 2x plus 1 times x minus 4. Minus, that's the mean difference for quotient rule, bottom prime top. So that's just going to be the x squared plus x plus 3. Keep it in parentheses because it's subtracted. All over the bottom squared, x minus 4 squared. When you simplify, I never multiply out the denominator because it's not useful. But I will multiply out the numerator so that I can combine like terms. So this gives me 2x squared plus x minus 8x minus 4 and minus x squared minus x minus 3. All over x minus 4 squared. And then I can combine my like terms. So that's going to give me x squared minus 8x and minus 7 all over the x minus 4 squared. Okay, so another quick example of quotient rule. So let's go ahead and go down and tackle these 4 practice problems. The guided practice problems. All right, so first, this is going to be my function 1, and this is going to be my function 2. So function 1 is the x squared plus 1, and its derivative is 2x. Function 2 is x to the 4th plus 3x minus 1, and its derivative is 4x cubed plus 3. So when we put our derivative together using our product rule, I'm going 1 prime 2, so that's 2x times x to the 4th plus 3x minus 1, plus, because it's product rule, these two multiply together. So x squared plus 1 times 4x cubed plus 3. With product rule, the order doesn't matter. The order in which you multiply or the order in which you add does not matter as long as you're kind of doing diagonals, if you think about it in terms of this setup. Simplify here, that's going to be 2x to the 5th plus 6x squared minus 2x. And over here we have 4x to the 5th plus 4x cubed plus 3x squared plus 3. And if we combine like terms, that's 6x to the 5th plus 4x cubed plus 9x squared minus 2x plus 3. On to number 2. Another product rule here because they're being multiplied, but this time I've got to deal with the square root of x here, so we don't want to forget about that. This will be my function 1. This will be my function 2. Function 1, I'm going to rewrite the square root as x to the 1/2 plus 2. And then find its derivative. So this is 1/2 x to the minus 1/2. The derivative of plus 2 is just 0. Function 2 is the x cubed minus 7x plus 4, and its derivative is 3x squared minus 7. That way, when I put this all together, we have 1 prime 2. So that is this diagonal 1/2 x to the minus 1/2 times x cubed minus 7x plus 4 plus the other diagonal, 3x squared minus 7 times x to the 1/2 plus 2. And then we want to simplify all of this. That's going to give me 1/2 x to the 5/2 minus 7 over 2 x to the 1/2 plus 2 x to the minus 1/2. Over here on the right, we're foiling. So the first two, that's going to be 3x to the 5/2 minus 7x to the 1/2 plus 6x squared minus 14. Then we can combine a couple of these. So this one and this one are like terms. So 1/2 and 3. So 3.5, which would be 7/2 x to the 5/2. These two are like terms. That's negative 21 over 2 x to the 1/2. And then I don't have any more like terms, but this one I want to rewrite without the negative. So that's 2 over x to the 1/2 plus 6x squared minus 14. Number 3, this one has a fraction, so we're thinking quotient rule. So I'm thinking tops and bottoms. So the top is 3x. The derivative of the top is 3. The bottom is x squared plus 1, and its derivative is 2x. That way, when I put this all together with my quotient rule, I want top prime bottom. So I want these two, 3 times x squared plus 1, minus these two, and that's 6x squared. All over the bottom squared, x squared plus 1 squared. If we simplify here, that's 3x squared plus 3 minus 6x squared. All over that same denominator, we don't have to multiply it out. And then combine your like terms, so that's negative 3x squared plus 3 all over x squared plus 1 squared. If you want to factor out a 3 or a negative 3, you can, but you don't have to. So there's my derivative. And lastly, number 4, my top is the square root of x, which I'm going to write as x to the 1/2 so that it's ready to take the derivative of. Its derivative is 1/2 x to the minus 1/2. The bottom is the 3x minus 2, and its derivative is just 3. That way, when I put this all together using quotient rule, I'm multiplying these two together. So 1/2 x to the minus 1/2 times 3x minus 2. Minus, that's the big difference with quotient rule, these two multiplied together, which is 3x to the 1/2. All over 3x minus 2 quantity squared. Okay, we want to simplify. So this is going to give us 3/2. X to the 1/2. Make sure you're adding exponents there. Minus 2 and 1/2 cancel, so I just have x to the minus 1/2. Minus 3x to the 1/2. All over 3x minus 2 squared. These two are now like terms, so I can add those two together. So negative 3 plus 3/2 gives me negative 3/2 x to the 1/2 minus x to the negative 1/2. Okay, now this gets a little bit tricky because if I want to get rid of that negative 1/2 power in the numerator, I'm going to have fractions and fractions. So we can do that. This just becomes 1 over x to the 1/2. But then I'm also going to want to get rid of my fractions and fractions. And that means I'm going to multiply through top and bottom by the denominators up top. So I want to clear this one and this one. So I'm going to multiply top and bottom by 2x to the 1/2. But if I do that in the big numerator, I'm going to have to do that down here as well. If you do that, that gives you negative 3. X to the 1/2 times x to the 1/2 is x. Minus 2 all over, and then you just write the 2x to the 1/2 out front times the 3x minus 2 squared. And that's my final answer. So that one had some tricky simplifying. but the procedure is the same.